Hello, my name is Mark Saunders and this YouTube video presentation is on describing the central tendency, which means it's about averages, and in particular we're going to look at three different types of average: the mode, the median and the mean. So we're going to look at ways of describing what the average is for different things, and this is part of a number of different video presentations I've done, which all can be seen on my YouTube channel, Mark Saunders on Research Methods, and you'll see the link for this on the bottom left of every single screen. So what are we going to be doing with this video? We're going to be looking at, first of all, at an overview of what we mean by measures of central tendency. So how would we say what the average or the norm was for this group of Lego people? And we're going to look at different ways of doing this. We're going to talk about modes, medians and means, and then as usual I'm going to finish with some further reading if you want to pursue this further. So when we say we're measuring the central tendency, what we're saying is we're using statistics or a statistic to give an impression of the values for a variable that are common or in the middle or average. So we're using one statistic or one value to describe a number of different data values there. And when in effect what we're doing is we're describing the middle. Now there are three main statistics for measuring a central tendency. The first, which is the mode, measures the value or values, because sometimes there can be more than one, but occur most frequently. The second, the median, is the middle point or the middle value after the data you've collected have been ranked in order from, say, lowest to highest. And the final main statistic we're going to be talking about is the mean. This is the one which we commonly refer to as the average, and it includes all our data values in the calculation. Now, the statistic we use depends on the type of data we have. And the mode we use with categorical data or data that is descriptive. The median we use with data which is numerical, and the mean we also use with data which is numerical. And so when we're talking about numerical data, we're talking about data which actually is made out of numbers, and numbers where we can either see the ratio, so we can see the number 4 is twice as big as number 2, or numbers where we can actually just see the difference between them. So with, for example, temperature, when we have a temperature of 5 degrees C, that is not double a temperature 2.5 degrees C, because the temperature scale goes into minus. So we cannot see the ratio, but we can actually see the difference between the values. But our main focus on this video presentation is to look at the mode, the median and the mean. The mode is used mostly with categorical data, and it uses nominal or descriptive data within this idea of categorical data. It can be used with numerical data, where you can say something like the modal group is people who are aged between 15 and 20, but normally we use it with categories. And the mode represents the value that occurs most frequently, and that means it's not affected by values which are more extreme in the distribution. So we could be saying, what's the average colour shirt of these people in the photograph? And when we look closely, we can see there are a range of different colour shirts. There's black shirts, blue shirts, purple shirts, red shirts, grey shirts and white shirts. And our question, what is the average colour, might be better phrased, because we're trying to really say which colour occurs the most often. And so to find that out, we count the different colours. We see that there were 6 black, 2 blue, 1 purple, 1 red, 3 grey and 4 white. And so we could really ask the question better if we said, what is the modal shirt colour? And if we group them together, we can see the modal is black, followed by white, a bit fewer, and so on. So that's the mode, the value that occurs the most often, in this case, colour, black. We can also work out the mode normally by creating a frequency table. And here we have a table just showing us, which we could have created in Excel perhaps, or some other statistical analysis software such as SPSS. And so here we can see the number, we can also see a percentage, and the modal colour is black, the one that occurs most often. If we now look at the median, this is used with numerical data which is interval or ratio data, and it represents the middle value or the midpoint. And just like the mode, it's not affected by the extremes in the distribution values. So here we have a series of 9 people, and their salaries that each of them earn is listed underneath. And as we can see, it ranges from the highest of 94,000 on the left hand side to the lowest for the third person along, which is 16,500. And to calculate the mode, we're going to have to do a little bit of work. The first thing we're going to have to do is to rank the data into ascending order. And so we've done that now, and as we can see, it starts out 1650 and works its way through to 94,000. And then once we've ranked it into order, we need to find the midpoint. So the easiest way to do that is to order them, so put the numbers 1, 2, 3, 4, which are the actual order, and then work out where the midpoint will be. And for these data, because we have 9 data values, the midpoint will be halfway through, which is at data value point number 5, which is 32,000. So we can say the median is 32,000. And this way of calculating works well for the median when we have an odd number of data points. However, sometimes we have an even number of data points. And here we can see we have 8 people and we're working out the median here. As before, we rank them into ascending order, and then we need to find the midpoint. So we put the numbers for the ranking, and then the midpoint this time for the median is halfway between points 4 and 5, which means our median is halfway between 27,000 and 32,000. In other words, 29,500. The final average we're going to look at is the mean. This is known as the arithmetic mean, if we give it its full name, and it's again used with numerical data. But this time all the data values are included in our calculation. So that means the highest value of 94,000 and the lowest value of 16,500 are both included. And this means that our data can be influenced by these extreme values. And this is especially so for distributions which are skewed. That means they're not symmetrical around the mean. So we need to think, how do we calculate the mean? And it's very straightforward because it's the calculation of the average, which I'm sure you've been doing for many years. To calculate the mean, we need to sum all the data values, in this case for each of the 9 people. And as you can see here, we start off with the person on the left at 94,000, then we add 18,000 for the next person, add 16,500 for the next person, and so on until we get to a total of 324,500. This is divided by the number of data values. In this case, we have 9 data values, 1 salary for each of the 9 people. And this gives us a mean, or what we often refer to as an average salary, of 36,056. It's interesting, if we compare the two, the mean salary for these 9 people is higher than the median salary of 32,000. And this is a function of the data for the amount people earn being skewed by the very high salary that the person on the left in the picture is earning. We can see this because if we leave out this high salary of 94,000, the mean salary for the remaining 8 people falls to 28,813. When we're looking at these statistics, there's a few bits of reading which are quite helpful. The book I wrote with Reva Berman Brown a few years ago is a very simple book on statistics, and it deals with the most basic statistics, and Chapter 5 includes some information all about calculating the mean, the median and mode as descriptive statistics, which measure the central tendency. Les Oakeshot's book, Essential Quantitative Methods of Business and Management and Finance, Chapter 4 there is on descriptive statistics, amongst other things. And finally, Chapter 12 of my own textbook with Phil and Adrian looks at descriptive statistics as part of analysing data quantitatively. I hope you found this video presentation useful, and please do look at my other presentations and do subscribe to my channel, Mark Saunders on Research Methods. Thank you.